For the computer science senior capstone projects, we worked with the Leeds School of Business on a variety of financial research projects. I'm Royce Schultz, and in the fall, I'll be starting my master's in computer science at NYU in New York.
Hi, my name is Chace Trevino, and after graduation, I will be a software engineer for Visa.
Hi, I'm Andrew Yee, and after graduation, I plan to work as a software engineer at Lucid.
Hello everyone, my name is Tianwei Zhao. I plan to work on the artificial intelligence stuff when I graduate.
And now we'll let our sponsor, Diego Garcia, introduce himself.
Hi, I'm Diego Garcia. I'm a faculty member at the Leeds School of Business, and I've been sponsoring senior capstone projects now for 3 years. I do research in natural language processing. I'm doing some stuff on economic history as well, and those are been the main two things that I've been trying to work with the computer science people. I like to have smart research assistants. Call me crazy. This year we did a bunch of things having to do with TV, business TV in particular, trying to understand what CNBC, Fox Business are talking about. And then we spent a bunch of time as well thinking about the past, in particular the Great Depression.
Our capstone consisted of 2 different projects. In the fall, we worked on a business TV transcript corpus project where we were tasked to scrape all of the business TV data from archive.org, stored in a database, so that we could perform different kind of analysis on the data. One of the analysis we were doing was sentiment analysis, and we tried to find a correlation between sentiment and text versus stock price movement. And in the spring, we worked on a project called Moody's Manuals. With this project, we were given many different scans of texts from old Moody's manuals, and our task was to identify company headers in the text and digitize them so that we can store it in a database and then also find the correlating company information with those headers. With that, I'll pass it on to Andrew so he can speak more about our business TV corpus project from the fall.
For the business TV transcript part of our project, which we worked on in the fall, we began by scraping TV transcript data off of archive.org from the major business TV networks, which were Bloomberg, Fox Business, and CNBC. This scraped data was then stored in our MongoDB database, where we were able to clean it using various methods, which included doing duplicate detection to find rerun TV shows from our dataset and remove them. We then modified our scraping and cleaning methods such that we could automatically update our database with new transcripts off of archive.org. To analyze our TV transcript data and correlate it to movements in the stock market, we use several methods, including the universal sentence encoder, sentiment analysis, various regression methods, and an LSTM neural network. Overall, we did find a correlation between the sentiment in the TV transcripts and movements in the stock market. However, our methods did not produce strong predictive results. Most of the time, they did not perform any better than random guessing and definitely did not outperform the general trend of the stock market. In the spring, for a separate class, part of our project team worked on creating a dashboard to better visualize our data using Grafana. The dashboard displayed a lot of useful information, including visualizations for price data, the frequency a topic was referenced in the transcripts, and a word cloud to better understand what was being said in the news. Now I'll hand it off to Royce to talk about the Moody's manuals, which we worked on this spring.
Moody's investment manuals began in the early 1900s and contain some of the earliest financial data that we have on American companies. Our task is to parse data from these pages so that the pages can be searched and so that we can track company performance over time between different editions of the manuals. This is especially challenging because we only have optical data from the scanned pages, and some of the scans are noisy with exposure issues or even deterioration of the original pages. So for our solution, we used a custom-trained object detection model created using the TensorFlow Object Detection API to identify company name headers on each page. Training and even predicting with object detection models is computationally expensive, so we used the NVIDIA Tesla GPUs available on the Summit Research Cluster provided by the university. Using a training set of only 1,000 hand-labeled pages, our model accurately detected locations for 86.3% of company headers, and using an open source text recognition model, we correctly identified 80.5% of company strings. With the power of machine learning, we're able to multiply our efforts and extend this model to over 60,000 scanned pages in our total data set. Now, Tianwei will give us an overview of our project benefits.
Thank you, Royce. Now let's talk about our project benefits. First, we built cloud service for data storage. The service is persistent and flexible. The data is easy to access. Second, we created an adaptable model to identify data in scanned pages. For the last one, we created evaluation methods for comparing different model architectures for identifying data in pages. Turn to the success metrics. For this part, we assist our sponsor in research effort and introduce modern software design principles. We create a system to maintain database of transcript from archive. We develop a method to identify company headers in Moody's menus. We practice industry standard software development skills. We develop ability to work as a part of a team, contribute to the same central code base, and communicate issues and discoveries with the rest of the team. Taking this point into account, we would say that our project is very successful.
When my team and I looked back on our year-long capstone, there were definitely lessons that we learned from the project. The first was that writing clean code that can be reproduced has long-term benefits even though it might take more time. The second is having a clear vision and communicating it between the team members is important for project success. And lastly, having an easily accessible persistent data solution is vital for long-term projects. Our team thanks our sponsor and the school for giving us this opportunity, and we're excited to take the next step in our careers.